In this session, we're going to walk through the configuration of MLAG on Arista switches. As we discussed in the MLAG overview, Arista's MLAG provides better bandwidth utilization and network device resiliency by combining two switches to look and act as one from the perspective of all devices that are dual home to both switches of an MLAG domain. When it comes to MLAG, there is a recommended order of configuration. Step 1 of the MLAG configuration is to confirm that the MLAG heartbeats are allowed on each switch's control plane. By default, Arista provides a control plane access list, and it is this access list that we're going to verify. Within that access list, there exists the MLAG keyword representing the port number used by MLAG, which is currently 11,111. Step 2 of configuring Arista's MLAG is to configure the MLAG peer link. Remember, we should use two links and combine them into a port channel, and in the case of Arista's modular chassis, we should use two links on two separate line cards for the best resiliency. Step 3 of Arista's MLAG configuration is to create the Layer 2 and Layer 3 elements of our MLAG VLAN. Step 4 is to define the MLAG domain. And finally, step 5 is to configure the MLAG member ports, which are the interfaces where the downstream devices are connected, such as other switches, routers, firewalls, and load balancers. Step 1's command is simply the show IP access list, or specifically, the show IP access list default control plane ACL. So if we issue the command show IP access-list and hit enter, we see our read-only default control plane ACL. And what we're looking for is the MLAG keyword for both TCP and UDP associations. For step 2, let's configure our MLAG peer link interfaces. I have a lab with 4 Arista switches up and running. Switch 1 and switch 2 are my spines, and they're going to be configured into an MLAG domain so that switch 3 and switch 4 see both switch 1 and switch 2 as just simply one switch. I've already configured switch 2 so that when we're done configuring switch 1, we can see the results. I also went ahead and configured switches 3 and 4 into their own MLAG domain. So when we get done with the example configuration walkthrough of switch 1, we'll see our MLAG fully running. Switch 1 and switch 2 have two physical links connecting them. We'll verify that they can see each other by issuing the command show LLDP neighbor. And on switch 1, we can see switch 2 on both Ethernet 1 as well as on Ethernet 2. So we know we have good connectivity between the two switches. Next, we want to configure Ethernet 1 and Ethernet 2 of switch 1 into a single port channel. So config, interface, Ethernet 1, enter, switch port, enter, switch port, mode, trunk, and then channel dash group, in this case we're going to use the number 10, mode, active, enter. And now we need to repeat that for interface Ethernet 2. So interface Ethernet 2, enter, switch port, mode, trunk, and channel group 10, mode, active, enter. Now we're going to get into the port channel and configure it with the description and the trunk mode. So interface, port channel 10, enter, description, MLAG, peer link, enter, switch port, enter, and switch port, mode, trunk. Let's verify that our port channel 10 configuration is complete and that the links are up between switch 1 and switch 2. I can do that while I'm in configuration mode, or I can get back out of it. In this example, I'm going to get out of configuration mode. We could type show run interface port channel 10, enter, and we can see our description in the switch port, and we can issue the show interface port channel 10, enter, where we see our interface is up, and we can see that both Ethernet 1 and Ethernet 2 are members of the port channel. For step 3, we need to configure the MLAG VLAN and create the MLAG VLAN interface, or SVI. So on switch 1, We'll get back into config mode and we'll use VLAN 4094. This is the one used as an example in the Arista documentation and one that I commonly use in a production network. I like to name my VLANs, so I'm going to name this the MLAG VLAN, enter. And then we're going to add additional command here, trunk group, and we're going to call it MLAG peer, enter. So note, the trunk group command will be associated to the port channel 10 that runs between switch 1 and switch 2. This command ensures that our MLAG VLAN, VLAN 4094, is never included on any other trunk ports that we create on the switch. So this is extremely helpful because as part of the MLAG configuration, we're going to turn off spanning tree for VLAN 4094. We turn off spanning tree on that VLAN so that we can ensure our MLAG peer link interfaces are always forwarding and are never put into blocking mode by spanning tree. So the trunk group command helps exclude VLAN 4094 from running on any other interfaces on switch 1 or switch 2 as members of this MLAG domain. So now we apply this trunk group command to our port channel 10, which is our MLAG peer interface. So we go to interface, port channel 10, enter, switch port, trunk, group, and then the group name MLAG peer, enter. Now, for the part that you probably aren't used to doing in your network, we're going to turn off spanning tree for VLAN 4094. And this is because VLAN 4094 only runs on the MLAG peer link, and we want to ensure that we never go into spanning tree blocking mode. So I'm going to exit out of this, get back to global config, and then type no spanning tree VLAN 4094, enter. The next portion of this step is to create the layer 3 VLAN interface, or the SVI, for our MLAG VLAN 4094. So that command is interface VLAN 4094, and again, I like descriptions, so I'm going to put in a description, MLAG peer link, enter. And then we're going to assign an IP address, and in this lab, I'm using 172.16.11.1 on a /30, enter. And then I can get out of config mode. We want to verify IP reachability since I've already fully configured switch 2. So let's ping 172.16.11.2, which is switch 2 MLAG VLAN SVI. And we got pretty quick response there. We see that we can reach it. So for step 4, we define the MLAG domain. The MLAG command puts us into MLAG configuration mode. So config MLAG, enter. And then next we define the local interface, or SVI, of VLAN 4094. So local interface VLAN 4094, enter. And then we configure the MLAG peer IP address. So that's peer-address, and then 172.16.11.2, enter. Then we tell the switch which interface our MLAG peer link is using. And so that command is peer-link, and then the port channel 10, enter. And finally, we name the MLAG domain by providing it an MLAG domain ID. So the command is domain ID space, and we're going to call this MLAG01, enter. Note that the domain ID is case sensitive and it must match on the two MLAG peers. And then finally, in step 5, we configure any or all of our MLAG member ports. So in this lab, we're going to configure interface Ethernet 3 and interface Ethernet 4 of switch 1. Both those interfaces connect to switch 3 and switch 4 downstream. Rather than configuring each interface individually, I want to show you how to take advantage of a range option. So I'll get out of MLAG config back into global config, and here I'll type interface Ethernet 3-4, enter, so I can configure both interfaces at the same time. So switch port, enter, switch port, space mode, space trunk, enter, and then channel dash group, and we're going to use port channel 34, and then mode space active, enter. And now I'm going to get into that interface port channel 34, enter, switch port mode trunk. And finally, to make it an MLAG member port, we're going to assign it MLAG 34. That tells our switch that this port channel is an MLAG member port. Now we can start the process of verifying our MLAG configuration. We can use the commands show MLAG detail, and show MLAG interfaces. So let's get out of config mode by typing end, enter, and then we'll issue the command show MLAG, enter. And here we can see our MLAG domain, MLAG01, our local interface, VLAN 4094, the peer address that we entered, the 172.16.11.2, our peer link that we're using, which is port channel 10, to the other switch in this MLAG domain, which is switch 2. And we can see that our state, we're active, negotiation status has us at connected, and we're up. We can also issue the command show MLAG detail to get a little more information. If I spacebar through that, we can see the additional information includes our state. So this switch is the secondary of the MLAG domain. Any state changes, the last time we had a state change, reload delay, LACP information, and our heartbeat timeouts. Now our downstream switches, switch 3 and switch 4, both view their physical connections to switch 1 and switch 2 as one combined switch. And we have active forwarding for twice the bandwidth with much lower oversubscription and better resiliency. And we can additionally enter the command show interface status pipe include connected, enter, to see that our port channel MLAG peer link was two 10 gig interfaces, so now they're running at 20. And our port channel 34, where switch 3 and switch 4 are connected, are now running as a combined 4 gig because each one of those have a 1 gig link and they are also in an MLAG peer. So now we have 4 gig of forwarding between the two MLAG domains. And with that, this concludes our session on configuring Arista's MLAG feature.